Hello guys, good afternoon. My name is Mohammad Sabir and today I am here with you. In these sessions, we are going to discuss actual vapor compression cycle. The first, you have to understand the first ideal compression vapor compression cycle. Then we look into the actual vapor compression cycle. What basically happen? Uh, we have a state one. Basically, the air, basically the refrigerant comes from a state first having a having a high temperature, having a low temperature. When it interacts with a ambient temperature, it basically gain a heat and goes to the state one, and then the pressures friction loss will be there, 1a2 1a2 intermediate state, and then intermediate state to next stage. Here what basically happen to due to entering of the entering entering when it enters into the compressor wall. uh, Here compressor loss will be there, and then the compression basically, here the polytropic compressions. Okay, here the polytropic compressions, also heat transfer takes place, and further pressure loss due to wall, and then further like pressure loss due to pressure loss due to frictions. And here basically you know in a cooler basically a pressure rise, uh, the pressure may rise, because what, why? Because here the liquid changes with a gases. uh, Gases changes with liquid, basically it loses the kinetic energy. It loses the kinetic energy, and gain it loses the kinetic energy and gain basically a pressure energy. Due to that, the pressure may rise, and like you know we get a state 3 at a sub 2 regions. And due to ambient heat additions, what basically happens, the point 3 shift towards the a 3a point, and then we come to the isentropic expansions, like isentropic expansion. What basically the pressures is high, the pressure is high compared to state 1, and then a pressure loss there. There is a pressure loss due to, we have a two reasons basically. One basically is due to the momentum loss, and due to the friction, because it converts gases medium to the due to momentum gain. Basically it converts to the gases. Okay, this is the simple actual vapor compression cycle. And now we come to the refrigerant. The refrigerant is a medium of heat transfer through phase changes during the process of refrigeration, with some exceptions where sensible energy transfer takes place. There are many substances which are used in refrigerant system for energy transfer process. Thermodynamic, normal boiling point, condensing and evaporating pressure, critical temperature and pressure, freezing point, function vapor volume. These are so simple properties. This is a simple relations you should keep in your mind. Del P upon del Ts is equal to Ps lambda R Ts square. Basically, it relates the pressure and latent heat is the contradictory thing. Clapeyron equations. High boiling, like theory of thermodynamic similarity. High boiling substances are in general low pressure refrigerant, and low boiling refrigerants are the highly pressure refrigerant. Because it easily you can visualize from these equations how this possible. And the high boiling refrigerant have higher pressure ratio, and lower boiling refrigerant have a lower pressure ratio. Easily you can prove by these equations. And high boiling have high latent heat of vaporizations. High boiling have high rated heat of vaporizations. The critical temperature and pressure. The critical temperature of the refrigerant should be higher than the temperature occurring within the condenser for a easy condensation of the refrigerant vapor. For the COP of the critical temperature should be very high so that the condenser temperature line of PA diagram is far away from critical. It's easy. This issue the considering better refrigerations like the actually the cycles far from the critical point should be far from the critical point to better performance. The refrigerant must operate in cycle above freezing point. The low freezing point is necessary because the refrigerant should not freeze in the cycle. Therefore, the refrigerant must have a freezing point below the operating temperature. Volume of suction pressure. Because if the volume of the refrigerant required for part of refrigerant decide the size of compressor. If the specific volume is high, com- the size of the compressor goes up. The reciprocating compressors are the recommended for the high pressure and small volume of suction vapor. The centrifugal compressors are used to handle large volume at lower pressure. Centrifugal compressors are used to handle large volume at lower pressure. This is the so important thing. Like in a reciprocating compressor, we get a high pressure and coefficient performance accordingly. Uh, according to CO, like half of COP, we decide the which refrigerant we should use, and then chemical requirement, flammability, toxic reaction with water, action with oil, material of construction. There are also a lot of factors we have to look into that before selecting a refrigerant for a refrigeration cycle. And then come to the physical requirement, thermal conductivity, low viscosity, and high direct resistance, heat capacity should be high, leakage tendency. And there are a lot of factors you can look. This is so simple. Thank you. All the best.